All right, welcome back everybody. Today we'll be talking about the readings that you did, lessons on objects, types, and expressions, and we'll be introducing perhaps the most important and exciting concept in this course, which is the concept of functions. We'll be spending quite a bit of time with functions through the semester, and we're starting with them early to give you the most time possible to get comfortable with them. Today's woodland scene, I want you to take note of the string lights of this tea and programming party that these woodland creatures are having. We'll come back to this later, but let's jump right into it. So some announcements. First of all, if you had trouble with software setup, don't feel stressed. If for some reason your dev container didn't start up or things are still a little bit awry, don't worry about that. We will be having office hours starting today at 11 a.m., so not long. By the time you walk over to Sitterson, we'll be open. And I'll talk about how office hours works momentarily, and after we do some warm-up questions. We can help you get going. You've still got time to complete the setup today, no stress, and you'll have plenty of time to get through exercise 0. The first exercise is mostly a follow-along tutorial, so it's different than the exercises you'll have starting with the next one, where we ask you to do something on your own, and you've got to come up with the code in order to implement it. Of course, we'll be trying to guide you through this in a productive way, but in this exercise in particular, we're giving you sort of exactly what you want to be doing, trying to explain it step by step so that you understand what's going on, and it confirms that your software is set up properly, that you understand how to submit something to Gradescope that's a programming exercise, how to see autograder results, and so on. Today we're going to be doing things on paper and pencil or iPad and pencil, so you can have laptops away, and we'll be doing pair work. So this will be, you can be a group of 3, but I am going to ask that you work with someone beside of you or 2 people beside of you. If you've got 4 people, just split up into 2s for today, and that'll be fine. So we're going to jump right into some practice based on the lessons that you submitted. We've got 4 questions, and what I'd like you to do is on your paper or your iPad, jot down your responses to these 4 questions and talk about it with your pair. Because we're still getting to know each other in this course, there's a high likelihood that the person you're sitting beside you do not know, so please introduce yourself. Spend a minute getting to know a little bit about each other, and then dive right into these 4 questions. The TAs will be circulating around the room. These will be the people walking. And if you have questions or want to talk about these things, I would highly encourage it. do discuss your results with your neighbor. We'll have 3 more minutes on these 4 questions. 3 more minutes. Two more minutes on this, 2 more minutes. And if you're sitting alone, I would encourage you to bunch up with someone on a row near you, beside you, behind you, so that you're able to talk. One more minute on these, 1 more minute. All right. Sounds like folks are coming to a conclusion here. I forgot to preface a justification for why are we doing this on pencil and paper or an iPad. And actually, I probably would generally encourage a pencil and paper because one of the reasons we do many of the practices we do is getting you prepared for quizzes. So our first quiz is a week from Thursday. And the types of questions you can expect on a quiz are very similar to the types of questions that we're doing in class. On these, there's not a whole lot to work out step by step. We've got a few more of these practice questions, and there will be some where you're trying to work them out step by step. And getting practice on pencil and paper, as opposed to trying to type it in or check something on the computer or look something up, will help you practice. So with that said, I would love to hear from you all on some of these. And I'm going to ask to, if you came into this course with prior programming experience, refrain from responding. I'd love to hear from people who are new to programming in this course and would like to tell me what's the difference between an int and a float. All right. I'm going to hand you the die here.
My favorite.
Yeah.
What I wrote down was integer, which is basically anything that's like a 0 or that can go from up and down, so non-numbers. And then floats are just decimals.
Right.
So they're kind of similar.
Yeah, they're similar. They're both numerical data types that you can perform mathematical operations on. And we think of integers as 0, 1, 2, 3. You can't have fractional components or they're not rational. And floats, on the other hand, are what you would think of as numbers that can include decimals and have more precision to them, 1.5, 3.14. And the name float is kind of confusing. Why not just call it decimal? It has to do with some of what you read about, this notion that we have in our computer, what's representing a float is a fixed number of bytes, and this is beyond your what you totally need to know. And the decimal point can float in there, kind of like almost scientific notation. We can move the decimal around based on some exponent. It's a very similar concept with floats. That's all more than you need to know. The main thing that you need to know about floats is when you need more precision than just an integer, you should probably use a float. You might wonder, why do we even have integers? Well, we'll come to find that in programming, counting things is very common and a very important concept. So we want to count the number of reviews on some product on Amazon or the number of likes on a TikTok. We're going to store that as an integer. Whereas if we wanted the price of something on Etsy, we're going to store that as a float instead. All right? Great. So what about, is there a difference between true surrounded in double quotes and true not surrounded in double quotes? Anyone want to take a stab here? All right. You ready to catch this? Let me put my pencil down.
True in quotation marks is a string, it's just text, and true without the quotation marks is a Boolean value, meaning it's like a true or false thing, like a 1 or a 0, I guess.
Absolutely, great work. So when we have two strings, oh, sorry, I should have dove for it. When we have strings, one of the ways that you can tell strings or string literals is that they're surrounded in double quotes. By convention in this course, we're going to surround them in double quotes. We've got a question about single quotes on the next slide, I believe. But string values are for textual values primarily. And as you learn, text isn't limited to just letters. It can contain other character sets. If we had katakana or hiragana in the Japanese alphabet, we could store those in strings. Emojis are string data. Spaces, punctuation, things like that are string data, and so on. Whereas the keyword true in Python with a capital T, and that's important because Python is a case-sensitive programming language, meaning that if you typed true with any other arrangement of capitalization or lowercase, it would not be the value true. But capital T true is a Boolean value that, means that's truthy. It means yes, it means true. And we're not going to spend a lot of time on Booleans over the next couple of weeks, but we'll come back to them as we learn some new concepts that allow us to make our programs behave in different ways depending on certain conditions. So if you selected yes, I want to save something, you'll do one thing. If you selected no, we'll do something else. So our programs can ultimately have multiple paths through them depending on the user's choices. Booleans will become very important then. For now, we're going to focus more on strings and numerical data. With that in mind, what is the difference between 1 plus 1 and quote 1 plus quote 1? Yeah, we got an answer up here.
1 plus 1 will equal 2, and quote 1 plus quote 1 will equal 1, 1.
Great. So I'm going to use slightly different terminology, and I'm going to encourage slightly different terminology for reasons that we will come to. And I'm going to ask you to try and, as we're thinking about evaluating an expression, so both of these are expressions, right? So this is an expression, and this is an expression. And the responder was exactly correct that the first one will evaluate to 2, and the second one will evaluate to 1, 1, the string. I'm going to encourage you, as you're getting used to the idea of evaluating expressions, to try and avoid using is equal to, and instead use the phrase evaluates to. In these cases, that's sort of a minute difference, but when we start having some variables or parameters, which we'll learn about soon, it's not necessarily going to always equal something. It's going to be the evaluation of this expression. And this will help us avoid confusing the idea of equality, which we'll learn about later, with evaluation. So if we wrote these expressions in a program and we asked Python, OK, we're ready for you to evaluate this expression, the first one would evaluate to 2. And it would specifically be 2 of type int. And the second one would evaluate to the string 1, 1, type str. All right. And last, what role do types play for data in Python, sort of at a large, in the large, or in a big picture? Anyone else have a response here? Yeah?
You can do different things with different types. For example, for Boolean values, you can use them to make like logical decisions. And as you said earlier, you can use integers for like counting things and programming.
Fantastic. The big idea of types is they tell you what you can do with values that are of that type. Types tell you what data is capable of. And so in this example, we had two integers, 1 and 1. Both are integer literals, meaning we literally wrote 1 here. And because of that, this type tells us, okay, the addition, the plus symbol means addition when we have two integers. And the plus symbol means addition just because we know their types. So that's what's informing this. Whereas the plus symbol, when we have string data, is not the addition operator. It's the concatenation operator. And that, as you read about, is from our friends in chemistry, where we're concatenating chains of molecules. Well, here we're concatenating two strings that will evaluate to one larger string. We're binding them together at this point and taking two strings, making one new string that is larger. More generally, though, as this question is alluding to, types are very important. And this is why we're going to specify them and think about them very deeply, because they tell you what you can do with the data in your program. And ultimately, if you do things that you're supposed to do with data in your program, you'll avoid errors, and your program will behave as you would expect. Any questions on these 4 questions before we move on? All right. And actually, before we move on, I want to spend just one moment to go around the room. You all have already met Ryan, so I'm gonna pass to you and give the TAs a chance to introduce themselves. Just briefly, name, year, and where you're from. And take notice of who's around the room because they can help you in discussions as you're having questions.
Hi everyone, my name is Yuan. I am currently a sophomore majoring in computer science and statistics, and I'm from Hong Kong, China.
And we'll just keep going around the room.
Hi, I'm Connor. I'm a sophomore majoring in computer science. I'm from Garner, North Carolina.
Hi, I'm Megan. I'm a senior and I'm studying computer science and business, and I'm from Chapel Hill.
Hi,
Tap it. There you go.
okay. I'm Aiden. I'm a senior from Raleigh studying computer science.
Hi. Hi, I'm Shritan, and I'm a sophomore majoring in computer science. I'm from Waxhaw, North Carolina.
Good. I'm Bernie. I'm a junior. I'm studying business and computer science with a minor in math.
Speak loudly, Sonny. We need to be able to hear you from back here.
Hi, I'm Sunny. I am a junior studying computer science, economics, and minoring in business, and I'm from Cleveland, Ohio.
Hey, I'm Luke. I'm a freshman majoring in comp sci and stats, and I'm from Asheville.
All right, round of applause for TAs. Again, these folks will be joining us. We'll be shaking it up through the semester, but they'll be here on Tuesdays for the foreseeable future. So again, they're here for you. If you have questions when you're talking through things with your neighbor, do ask, and they can help. So let's move on, and let's take on 4 more. So I'm going to turn it back over to you for about 5-6 minutes, and then we'll bring it back to the front once more. You'll just have to be careful to not hurt anyone. Yeah. More minutes, and then we'll discuss together. One more minute. All right. It's looking like you all have, for the most part, gotten through these four. So let's go ahead and discuss. For the very first one, what does the len function evaluate to when applied to a string or a str value? What will the expression len of string owl evaluate to? We've got the die over here. Get the TAs to run around the class. Who wants to respond to this one? All right.
I think it's going to give you the length of the string.
Yep.
And for this one, it's going to evaluate to 3.
Great. So len is short for length. Great work. And so len is length. And for now, the only thing that we care about the length of are strings because they are what we would technically call a sequence type. They're made up of a sequence of characters. The order matters. Right? And this is especially obvious with strings because owl is different from WOL. I don't know what that is, but that's a different string. It has a different meaning than the string owl, given the particular order of these letters. So a sequence we'll spend more time with later in the semester, but the very first sequence that you're seeing is a string, and the len function works on all sequences. Tells you the length or the number of items in a given sequence, and in a string it tells us how many characters there are. And this is len owl. This has 3 characters in it, so that's going to be 3. You know, I could have made this slightly more interesting, and I want to give you one more example just to be sure we're on the same page here. If I had the string hi owl, and there was a singular space here, the length of this string would be 6, right? Because we have 2 for hi, 1 for space, and 3 for owl. So spaces, numbers, punctuation, emoji, things like that will count towards the length of a string. As you get into, they count as the length of the string. I'm not going to give you, as you get into upper division computer science classes, you will learn a little bit more nuance than that. But for now, each character counts as 1 length of this string. Is there a difference between double quote true and single quote true, and what type of literal are these expressions? Who wants to respond to this one? All right, we got it in the back. Coming at you.
I think they're both strings.
Great, they're both strings. Is there a difference? No, they're exactly the same. We're going to have a convention in this course of tending to use double quotes, but I want to point out to you that and as was mentioned in the reading, briefly, single quotes are fine. And so you'll see single quotes in places. If you go out and search the internet, you might see examples of single quotes. There's no difference between these two. You might wonder, why do we have both of them? Well, there are cases where one might be more convenient than the other. For example, if I wanted to represent the owl says hi, one more thing you read about was, if we have double quotes inside of double quotes, the way we know that a string is based on a pair of matching double quotes. And here we've got 4 of them. How does Python's not the brightest and doesn't try and jump to a conclusion about what it is that you're saying. It follows very specific rules. Well, we learned there's one way of doing this, which is escaping. So you put a backslash in front of these double quotes, and that says treat this as the character double quote within the string. But for some justification for why you might want to use single quotes is if you put them in single quotes, the owl, says hi, this would work okay, right? Because the single quotes are what's pairing the outermost expression here and saying this is a big string, this is all character data, and then we can use double quotes inside of it. Again, that's a little bit beyond our concern, but you will see single quotes at times, and I just want you not to feel confused by them. What are the square brackets called in the following expression, and what does it evaluate to? Who wants to try on this one? All right, here we go.
So the square brackets represent indexing the word, and for bear, it would give you R, since it's the 4th letter, because 0 accounts for B as well.
Great. So this is what we call indexing. You'll also see this particular operator, the square brackets, called subscription notation. Oh no. One sec. There we go. My bad. Subscription notation, which, if you remember, if in math, that would be like, bear, and then a 3 down here, like in a subscript. And so you can kind of think of it like that, and it makes more sense in a mathematical context in that way. But what you're saying is exactly right. We are going to use this to try and look for a specific item at a specific index within our sequence. And here with bear, as a reminder, all sequences start with 0, 1, 2, 3. So if we asked for the item at index 3, we would get back the single character string R as what exists there. Great. And then last question is, can a string be a number in Python? Yeah, we've got a response back here coming around with the die. Okay, yeah. Question first.
With OWL, with the first question, number 5, does it, like with bear, you do 0, 1, 2, 3, so is owl 2 characters or 3 characters? You start with 0.
Great question. So the question here is about indexing. And if we wanted to ask the same question here with owl, I'm going to write in the top right corner in purple. Oops. All right. So owl index 0 would be the O, index 1 would be the W, and index 2 would be the L. And so if you ask for index 3 of owl, you would get an error saying that index does not exist in this string. We only have 3 indices available. But if you ask for index 0 in either, you would expect the very first character, and so on. But you do have to be careful about this. And this is one of the reasons why the len function exists, right? So that you can check to be sure when we get there that if you're looking for something, some index, you can check, does this index even exist based on the length of the string? And you could determine that, right? So if the length of the string is 3, then you know index 3 or greater does not exist in that string. But we'll talk more about that as we reach that point. But that's a great question. How about the final question here? Can a string be a number in Python? Got an answer here, coming to with the die.
So I'd say like yes and no.
Great.
Because yes, because it'll be like you'll see visually a number, but no, because it won't function as like a normal number would.
Fantastic. I was hoping that you all would pick up on this. This one is a sort of ambiguous question, right? And it can go either way. It can be argued either way. It's not necessarily correct one way or the other. And what do we mean by a string being a number? Well, you know, a string 110 that's kind of a number, right? And you could say that this is a number. We could convert it into an int value using the int constructor if we wanted. Like that, and we would get an integer out of that by taking the string and converting it to an integer. But on its own, the string 110 does kind of represent a number. It's got some numerical data in it. For us, it represents a number. But you never really, it's a type of number that you don't carry out arithmetic on, right? You don't say like 110 plus n is something meaningful, right? You never, with strings, you don't tend to do arithmetic on it. Same with your PIDs, your 9-digit PIDs. They're numbers, but they're not really things that you do computations on, right? So in a way, they can have numerical data embedded in them, but they're not numbers that you can do computation on or arithmetic on until you convert into a numerical type, like int or float. Any questions on these before we move on? All right, we got one more set of these, and these are for operators and expressions. We've got 3 expressions in the first question, and continues on from there. So I'll turn it over to you all to take it from here. And keep discussing with your neighbors. If you want to meet more neighbors, I encourage it. 1 more minute on these. 1 more minute. Twenty more seconds. 20 more seconds. All right. Who wants to take a stab at the first expression here? 10 percentage symbol 3. Dies coming around. We found a hand. Explain what this means and then what you would expect the result to be.
Yeah, so for the 10 percentage 3, that would give the remainder of 10 divided by 3, which would be 1, because it would be 3 1/3. So it would just give the 1, that's the remainder there.
Great. So remainder, when you divide 10 by 3 using integer division like you learned a long time ago, how many are left over? This operator can feel confusing to first-time programmers because you haven't thought in terms of remainders in even division in quite some time. And my favorite analogy for remainders is if you have 10 people, which is your left-hand side operator here of this percentage operator. If you had 10 people and you wanted to form teams of 3, how many are remaining after you've done so, right? You can use the true, the division of taking the decimal division and then multiplying it by what you've divided by. But for many numbers, I find it simpler to think about, in cases like 0.3 times 3, 0.3 remaining times 3, we all know that to be 1. But for some reason in my mind, it works a little bit more easily thinking about how many people on the left, team size on the right, and just figuring out how many people aren't on a team. And do you want to take on the double slash as well?
Yeah. So it's kind of like the inverse of the remainder almost. So for the first one, it was 3 1/3, and it outputted 1. So this would output 3 because it's how many times 3 goes into 10 without the remainder.
Great. How many times does 3 divide evenly into 10? Right. So 10 divided by 3, and then you just throw away any remainder, throw away any decimal, and that's what you have left over. So that's the base. And the last question here. Come in with a die. Yep.
Just speak here.
Oh, okay. Yeah. First, a question about the double slash. Would the resulting number be an int or a float?
Great question. I'm glad you asked. In both of these cases, you expect back, so in these two cases, they would be ints.
Okay.
And typically, you're only using these operators on integer values. It turns out if you, and I tried this because I had to remember, and I think I actually can never remember a time where I wanted to use either of these operators with a float, but if you use them with a float, you'll get a float back out of it. It's so uncommon though, because they're meant to be used on integers that really I would focus on understanding how these work with integers, and the special case of working with floats is a little bit beyond our concern. That's a great question though. Do you want to take a stab at the 2 stars here?
Yeah, so the 10, 2 stars, 3, it's 10 raised to the 3, so 1,000?
Yeah, 1,000. 10 to the 3rd, right? So in mathematical notation, we would use an exponent, an exponent. But we don't really, it's not easy to type exponents in plain text, so most programming languages choose some kind of operator. Your calculators would often use the caret. And I want you to be careful not to use the caret in Python. Use the double asterisk, because the caret means something else. It's not anything we'll ever use in this course, but if you take upper division courses, you'll learn more about what the caret might mean. All right. Let's move on to, is there an error in the expression string camp plus int 110? And if so, how would you fix it such that this plus symbol would be concatenation? Who wants to take a stab at this one? All right, coming up with a die. And by the way, the reason we use the die is not only so you can hear each other in class, but so that on the recording, you'll be able to hear the questions that were asked as well.
Yes, there is. The first one is a string, the other one is an integer. And in order to evaluate to something, you should put the 110 inside quotation marks, so it can both be a string.
Great. So there are a couple of ways to fix this, and the most obvious would be, put some quotations around this. It turns out if you were writing this code, I would encourage you to probably not use concatenation at all. If you knew that you wanted COMP110 to be all one string, you could just write it all as one string without the concatenation, and that would be fine. And then the other way that you could do this, you could imagine that 110 is something that the user gave us, some variable or what we'll see is called a parameter. You could also have used the string function to change 110 into a string. So that would have looked like camp plus stir the int 110, right? And so you learned a little bit about the functions, which we think of as constructors, because they're constructing a different kind of object or a new kind of object. And here we can take an integer, give it to the string constructor, and it will give us a string back that would allow us to concatenate it in this way. So one of the things that is a big idea about expressions, and these are all expressions that we're looking at on this slide, is there are many different ways to write them that have trade-offs, but it gives us some flexibility. Ultimately, an expression is something that will evaluate down to a single value of a single type when the program is running and when Python evaluates it. All right, how about what is the evaluation of the expression 10 over 4 or 10 slash 4? What types are the operands 10 and 4? So we call operands the things on either side of an operator. And what type does this expression evaluate to? Anyone want to take a stab at this one? All right. Oh, this is a very kind way of getting the die somewhere. We're gonna have to start checking.
So the evaluation equals 2.5, and the operands type is an integer, while the expression evaluates to a float.
Great. Fantastic recollection of how the division operator works. So a key difference between the double division sign and the single division sign is this one works how you would expect. And even if you give it 2 integers as its operands, it's going to give back to you a float, right? And so this will result in a float, and that's typically what you want. It would be, it's more common that if you wanted to do division that you don't want to accidentally get rid of some fractional value, so we're going to give you back a float. Whereas if you're wanting to go out of your way, you've got 2 integers, and you want to do integer division and get rid of the remainder, that's why we ask you, and Python asks you to enter the second slash, and this is what differentiates integer division from floating point division. And lastly, we've got this evaluation of the expression down below. Does anyone want to take a stab at reminding me the order of operations for this? We've got it up here. The die is coming. Actually, I'll just call out what's the first operator to evaluate? Multiplication. That's a hot take. I'm actually going to, for time purposes, we're going to move through this. What would be the next operator that you would evaluate?
Division.
Division. All right, what would be the next operator you would evaluate?
Addition.
Addition. And then the last one?
Subtraction.
Subtraction. And what would you get if you did it in this order?
Well, you do 4 times 5, which would be 20, and then the 6 divided by 3 is 2. And then you then do the addition part first. So you say 22, but then subtract 2, so it'll be 20.
All right. So it turns out, due to the properties of math, the order in which you do multiplication and division and addition and subtraction may not matter in this particular one. But I do want to remind you generally, because there will be cases where this does matter, that in your PEMDAS, so parentheses, exponent, multiplication, division, and then addition, subtraction. So I learned this as PEMDAS, or please excuse my dear Aunt Sally. I've learned that that's a dated reference. But what I want to remind you of is that actually there's equal precedence for multiplication and division and addition and subtraction. And the way that Python and most programming languages will process this is left to right. So division first and then multiplication because it happened left first and right second. And then same with subtraction and addition. Turns out, again, it doesn't actually matter in this case as long as you're doing them in the right order, or at the one after the other. But technically, Python will evaluate it left to right for those same orders of precedence: multiplication, division, addition, and subtraction. There are special cases where this could matter, but it doesn't matter in this case. Yep, question here. You can call it out and I'll repeat it. Is 20 there a float value? Oh, yes. Thank you for pointing this out. This is absolutely correct. And this is important. Because of that division that's happening, this would have been a float value. Python and most programming languages have a convention, and that's very important. I really appreciate that comment. I would have been amiss if I had realized after class we didn't talk about this, so that's fantastic. Python and most programming languages have a convention that, we don't really want you to have to go to the trouble of converting all your ints to floats every time you want to add a float to an int or something like that. So the convention is if you have a mathematical operator where one operand is a float, it will automatically convert the other to a float and just treat it as a float thereon. Great observation. Yep, question here.
If there's an operator that, like that division, that makes it into a float, but it's at the end of the expression, like you had operators before that work with ints, would it still work for the whole thing?
Great question. So the question is, if there was a division operator, say at the very end, and it was the last of these to evaluate, maybe you had parentheses around it or something like that, it turns out it shouldn't really matter. Technically, the way the earlier evaluations is it would all be int as it simplifies. And then that last step would be, let's do division, and it becomes a float then. But you should get the same result either way. But if at some point, like here, if we had 7 divided by 3, then the other operations would have been in terms of that float, and it would have been taken a little bit more careful calculation to get to a final result. Yeah. All right. So we've got great work on these. I'm actually okay. So we're going to jump to the next sort of subject. So this is a topic that you all have not yet seen. Some of you may have had a preview of this if you jumped the gun on exercise 0 and you've looked at exercise 0. Some of this will be familiar. But if you haven't, that's where I would expect you to be right now. And we're going to start by learning the concept of functions, and I want to give you a chance to think about them intuitively. What you're about to see here, this code listing that's syntax highlighted with some color, is a function definition in Python. It's a new concept to you. And I don't want to actually explain anything. I want you to have a moment to try and have the experience of looking at some code that you've never seen before that contains ideas that you don't know anything about, besides some things that should look a little bit familiar. And then consider making use of this function. So if we define a function, that gives us the ability to call it from other places in our program, or after we've defined it, we can call our function. And there are 2 example function call expressions here. And what I'd like you to do is work with your neighbor for the next 5 minutes on the following prompt. What value and type does each function call expression? So these 2 expressions, what do they evaluate to, and what type do they evaluate to? And then lastly, what kinds of connections do you think you can make between the call and the definition? And I'm going to turn it over to you all to try this challenge out. The TAs will once again be coming around if you have questions or want to talk about your intuitions. 2 more minutes on this one. 2 more minutes. One more minute on this. 1 more minute. All right. I'm curious, how many of you got 0.0 float here versus 32.0 float here? If you got 0 float, raise your hand. If you got 32 float, raise your hand. All right, round of applause for you all. You successfully evaluated a function without having any help knowing what it was you were looking at, right? So your intuition did carry you here. And what we're seeing is a definition. And we'll break down what's going on here in just a moment. But note that this definition has a name, Celsius to Fahrenheit, and we're making use of that down here. We're saying, let's call this definition. And then in parentheses, we're saying here are the inputs, or this is what we're going to call an argument. So the degrees argument is going to be 0. And that's ultimately going to be assigned to this degrees parameter of the definition. So we're going to learn that the computer will jump into the definition and treat degrees as 0, the integer. Then when we jump in, we see that there's this one statement here, return. We don't know what that is, but it must mean that this is what this is going to evaluate to for this to make any sense. And then we're going to substitute degrees, so 0 multiplied by 9 divided by 5 plus 32. This simplifies down to 0 divided by 5 plus 32. This simplifies down to 0.0 plus 32. This simplifies down to 32.0, which is a float value. And then that's all we've got to do to simplify this return statement, and that's why this would result in a value of 32.0 of type float, right? We could run through that same set of steps again. I'm going to try and clear there we go. Oh, come on, Keynote. All right, float, I'll write down below for this one. So for this one, degrees of Fahrenheit, degrees is going to be 10, all right? So now degrees is going to be 10. The second time we make use of this function, we've got a different value for degrees. And I'm going to write the simplification of this return statement down below. So 10 multiplied by 9 divided by 5 plus 32. That simplifies down to 90 divided by 5 plus 32. That simplifies down to 18.0 a float plus 32. That simplifies down to 50.0, which is a float. And this result is what this function call would evaluate to, and it's a float. Question in the back here. The die is up here. Just go ahead and yell it out. Great question. So the question is, how long does a function definition stay around for? the very first exercise, you'll write a function definition in a Python file. And so we tend to write these in files whose extension is .py. And this is a Python module. And the direct answer to the question is, how long does this stay around for? It's however long that file exists for. So you've saved that function definition in your file. And then later, you'll go and ask Python, hey, load these definitions from this file up and let me make use of them. Or go run another program that uses this function that was saved. And then if you wanted to change the definition of this function, you'd have to make changes to that file, save it, and then they would persist on. I think this will start to feel pretty natural as we get into it. Great question. Other questions? Yeah?
If you're going to write another definition, but say it's like Fahrenheit to Celsius, do you still use the degrees operator?
Great question. So the question is, if we wanted to write the inverse of this, Fahrenheit to Celsius, could we still use what we're going to come to learn is called a parameter named degrees? And yes, the names we give to our parameters only have meaning within the context of that function definition. And we can use them when we call it to say, hey, Celsius to Fahrenheit, for this particular parameter, I want you to use the argument 10 or 0. But we can make reuse of those. We can't have two functions of the same name because Python wouldn't know which one we were referencing in this language. All right, great questions. All right, I want to talk very briefly about, this is going to be, actually, I'm going to come back to this. I want to talk about how this relates to the fundamental pattern, which we discussed on Thursday. And one of the ways you can try and think in your head about the definition of a function is that it becomes what we think of as sort of a black box. And that black box has some input holes where we can put our values into. This was the parameter named degrees, right? There's some algorithm. In this case, it was really just an expression, a singular formula. It wasn't really a full-fledged algorithm, but some process, some algorithm. Technically, there are steps involved in simplifying that expression, so we'll call it an algorithm. And then some result, right? In this case, it was, we're going to give you a float back. And once you have this box defined, you're able to make use of it multiple times over, right? So Celsius to Fahrenheit degrees 10. Later on, when we wanted to call this definition or make use of this function black box, we could make the expression, formulate it like this. And what happens is, just like what we evaluated together, that value 10 for degrees is sent into the input or assigned to this degrees parameter of the function. Some magic happens inside of this black box, right? Steps are happening. We're breaking down some function or breaking some evaluation down. And then ultimately, we produced a result of 50, which was of type float. And that's what this expression evaluated to, right? When the program ran. So in our code, we might write Celsius to Fahrenheit, but when we ask Python to evaluate that piece of code, at runtime, when our program is running, it's going to result in a value of 50. I'm going to post these slides to the course website after class, and I have some notes on them, mostly for the purposes of looking at them in posterity. We're not going to talk through this just step by step because we've just worked through this together. But the big idea is we can call this function many times, right? So before we break down the exact structure of a function, I want to give you one more analogy, which is a function definition is a lot like a recipe, right? These, as I mentioned, this is one of the most foundational concepts in computer science. It can feel a little bit intimidating because there is a lot of syntax. There are a number of pieces to bring together a function definition. But to hopefully help it feel a little bit more familiar, you can think of a function definition like a recipe. Just like a recipe does not result in a meal until you cook it, a function definition does not result in a value until you call it, right? Holding a recipe in your hand is not something you can eat. It's not delicious. I guess you could eat it, but it wouldn't be what the recipe is specifying that it is that you're eating. Similarly, with a function definition, it just exists. Once we've defined it, we haven't made use of it yet. We'll make use of a function definition with a function call, which is an expression that happens after a definition has been evaluated. Just like you can have adaptable recipes where you can substitute some key ingredients follow the same steps, but intentionally get something that's similar but a different result. You know, blueberry biscuits, cinnamon biscuits, sage biscuits. You're substituting some key ingredients there, but following similar sets of steps. With a parameterized function definition, which is a fancy academic $5 word, right? Parameterization is the notion of having that degrees parameter. So degrees is an int. We can pass this value in, and that's going to allow us to substitute different values into some algorithm such that we're intentionally getting different results. You know, we got a result of 32 degrees for Celsius of 0 and 50 degrees for Celsius of 10. And we substituted different inputs and still made meaningful use of this algorithm. And this is how we get flexible functions that we can reuse in different contexts. Just like recipes, function definitions are written down, we're defining them in our program so that they can be called once, twice, tens, hundreds, billions of times over. Every time a photo is liked on Instagram, a function is being called in your phone. Multiple functions, in fact, are being called in your phone. Multiple functions are being called somewhere out on the internet. Those functions were defined once and reused every time this is happening. All right. So let's break down the anatomy of a function definition. And this is the thing that I want to be sure that you're writing, you're jotting down on paper or on your iPad. All function definitions start out with the keyword def. This is short for define, right? So we're about to define a new function. We're writing down the recipe. We then give the name of a function. These tend to be, in Python, have a convention of being lowercase. And if you have multiple words in the name of a function, you'll separate them with underscores. So this is the name we're giving to the function. In our previous example, it was Celsius to Fahrenheit. It's good to use descriptive names. We then have our parameter list, right? So these are the inputs or the ingredients to our function definition. In this case, and in the first example, we had only one parameter defined. It turns out we can have multiple parameters to a function. One that we probably won't have time to get to today, but we'll come back to on Thursday, is if you wanted to calculate the perimeter of a rectangular shape, you need its length and its width. So we would need to define a function that had two parameters. We'll look at that. All we have to do is put a comma between the parameter and the type pairing. But this is saying, hey, in order to call this function, you're going to have to give me something of a value of this specific type that this parameter needs. So it needed an integer, or some will need strings, and we have flexibility there. We then have an arrow symbol formed by a dash and a greater than symbol. That's our return type. And this tells us what function calls evaluate to. Right? So this gives us a promise that, hey, if you call this function, that expression is going to result in this type. That's why in the Celsius to Fahrenheit, our parameter was, hey, you give me an integer. And then the return type was specified to be a float because the return statement returned a float value thanks to that division. Next, you'll see that by convention, we use something called a docstring, which you read about, which is a string that is meant for the documentation of some piece of code. In this case, it's documenting our function definition here. And then for now, we're going to use very simple function definitions. We'll learn how we can write more elaborate functions as we move through the course. But for now, all we need to know is that a function is going to have some return statement in it that's going to return an expression of type return type. And so in the Celsius to Fahrenheit example, that expression was the formula for taking degrees Celsius and converting it to degrees Fahrenheit, right? And that was an expression because it wasn't until we went and called this function definition that it did evaluate down to a single type or a single value of type float. All right. We're going to continue talking about this on in the class ahead, and I'll have some more notes and slides. I'm going to skip through this to give you an opportunity with your neighbor or your team of 3. Today, if you're sitting alone, I'll give you a free pass. You can submit this alone if you were alone. But the way that we're going to submit classwork is by taking a selfie. One of you will be the submitter. And I want you to hold up your anatomy of a function, give a cozy, happy, excited thumbs up. And on Gradescope, you'll submit this photo, and I'll give you all 5 minutes to do so. And I'll talk about office hours in 3 minutes. So go ahead and do this, and we'll talk about office hours in 3 minutes. One more minute on this, and then I want to talk about how office hours works. All right. All right. Let me very briefly talk about office hours, and then we'll close up. So office hours are open for drop-in appointments starting at 11 a.m. today, so in another 20 minutes. And to use office hours, you'll register on a site called CourseCare. And the enrollment code you can find in the Canvas announcement. We'll get it posted on the website as well. Is on this slide. I'll post these slides as well. The way it works is you come to Sitterson Hall. You take a seat in the open lobby area. You make a ticket on CourseCare, an appointment request, and you'll get called in one by one. These meetings are 15 minutes long. Gives us a chance to work through one issue. And then we do ask that there's an hour-long wait between subsequent tickets. And the reason for this is what we've said all along. The best way to become confident as a programmer and build your skills is to be sure you're working and improving your individual understanding. To give you a quick visual of how this works, first you'll see that we're open until 6 p.m. tonight. Won't be open until 8 p.m. tonight. You'll check in. The next button will show you how many people are queued. And then you'll be asked, are you coming for assignment help, like on an exercise, or conceptual help? And then the most important part of this that I want to talk about right now is that you're asked a few questions. And we ask that you genuinely respond to these questions and put effort into them. It will help make the office hours interaction more meaningful. By talking about what concepts you've tried, it helps you practice using those concepts in sentences and explaining yourself. And if you write just SOS, 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 or help, 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 the TAs are encouraged to cancel that ticket so that you have a chance to try again. You'll then see what number you are in line to be called in, and very quickly, your TA will be calling you in. That's all we've got for today. Do exercise 0 and come work with us in office hours if you have setup issues.